Hey everybody, I'm back with more of the same. I've got a new table of resistor values here. So I'm going to have gains of 10 and 1000. I could put gains of 100 in both the front end and the back end and still get a gain of 10,000. But this way, with these two setups, I can see what happens as I shift the gain from the front end to the back end. So no long talk about the circuit this time. I'm just going to get right into testing it. So I think now might be a good time to bring out some of this stuff. It's not drugs, it's actually conductive jelly. I mentioned in my first video that I had a friend who did EEG work a while back, and he gave me a couple of these tubes of conductive jelly to play with. That was actually years ago. I hope this stuff doesn't go bad. It's looking kind of yellow actually. Hopefully it still works. Actually does a pretty good job of cleaning these pennies. A nice shiny spot where I put the jelly on that nasty old tarnished penny. The reason it's in a scary looking syringe is because they had a little hat that had little holes for the electrodes, and they kind of had to... Never mind. So let's get right onto this. I'll tape these guys up. This first test is going to be with a front end gain of 10 and a back end gain of 100. Well, it's definitely working a lot better than last time. Heartbeat signal's a lot stronger. It doesn't look like it has 10 times the gain of the last amplifier that I used, but it's definitely working better. It's coming through pretty clear. Alright, so I'm going to stop it here and just back up to some nice data here. Yeah, this spot looks good. Let's grab that and I'll amplify it so you can see it. Actually, how much did I amplify that? About 18 dB. Okay. So there it is. It looks nice. I flipped the probes around from last time so it's right side up. But it actually looks pretty good, I think. That's much less amplification than in either of the last two cases. There's definitely some noise on there, which I might investigate a little bit. Let's get the next one set up. Alright, so I've got the next one all set up with the front end gain of about 1000 and the back end gain of 10. So let's just start recording. Again, I've got the fancy conductive jelly on there too. Let's turn this on first. There we go, and just make sure my DC offset doesn't fly away on me. It looks alright. And this looks awful. Let's see if I can get a better connection here. Yeah, this just looks awful. So it looks like it doesn't have nearly as much gain as I thought I gave it. I can still see a heartbeat in there. It's just a little pixel or two sticking up above that flat line. I'll grab a section and amplify it. Let's see, like 40 dB. So yeah, there's definitely a heartbeat in there, but it's a mess. It's way down in there. Yeah, I think something's just fundamentally wrong with this circuit. I probably have some wrong resistor values in there. So yeah, I'm going to have to take a look into this and fix it before I move on. I mean, the last setup worked, but I really want to get this one fixed so I can get a good comparison between the two setups so I can know what happens when I move the gain between the front end and back end. I can't really do that till this works. The first thing I thought of when I was trying to think of differences between those two cases was that I sort of fudged a bit with the gain equations and the resistor values. I just sort of neglected this one term out in front, and I just said, oh, 4.7, that's close enough to 5. When I go back through it, this one term here actually is kind of significant. When you have such a low gain in the front end. It's the case with the gain of 10 in the front end. And the case with the high front end gain of the low back end gain does have lower gain overall, but it still has about 90% of the gain overall that the other case did. So that does not add up to the huge difference that I saw in gains. And then I found that I had forgotten to change the back end gain from 100 down to 10 for this test. Then obviously it got even worse. Still a heartbeat in there, but it's even lower gain now, so there's definitely something wrong with the front end. It's probably something dumb. Alright, so it turns out I had the placement of one of my front end resistors wrong. I had put it between the two outputs of the front end op amps instead of between the two minus inputs. That means it was also wrong in that first test that I did, so I'm going to have to redo that too. But for now, let's redo this with the new fixed circuit. Alright, so right now I'm just holding the two signal electrodes together. I should be able to adjust this. Ew. So I have the adjustment knob all the way in one direction and it still shows a DC offset. And that's with 0 volts between those two inputs. Okay, maybe this will work. I'm just going to start recording and hopefully I get something out of it. Oh, look at that. That is something else. Yeah, so the DC offset is really a mess in the case with the high gain at the front end. And then we have to redo the case with the high gain at the back end with that resistor in the right place. And I'll see what happens then. Alright, I've got this set back up again with the front end gain of 10 and back end gain of 1000, but this time with the front end resistor in the right place. So again, I'm having some weird DC offset problems, but I think I can make it work. So let's start recording. Oh, there it goes. There it goes. That's nice. Let's stop this right here. So I had problems with DC offset in both of them, but I also want to go back and try the case with the gain of 1000 and see if that works out better now that I've fixed the mistake with the front end. I might just put another single-ended amplifier on the end of the in amp. That might be the best way of handling this DC offset problem while still getting all the gain that I need. So that should be enough for this video. I'll reduce the gain in the next video and see how much more manageable the DC offset is there. And then I'll keep going from that.